Well, hello there. In this video I'll show you how to build a new or upgrade your existing quadcopter using FPV360 Quadcopter upgrade kit. The main two parts you will receive in this kit are frame's top plate and the frame's bottom plate. They both made out of carbon fiber, 1.5 millimeters thick, so it's very strong material. So the first thing we will need to do is we'll need to separate these little parts away from the main body. In other words, everywhere you can see like the 2 millimeter wide joint between the main body and the little part is where we will need to make the cut. And that goes all the way around this main body for both the top plate and the bottom plate. Okay? To do the cutting, you could use any diagonal cutter or wire cutter. If you have like a rotary tool with a little cutoff wheel, they'll also work. My preference and suggestion to you guys is to use pliers that have one side of the edge is flush. If you compare it to these yellow pliers to these red ones, if you look at the edge, it's more like it's a wedge type or chisel type edge, and these they won't give you as clean of a cut. Okay, but these here, the cut will be much cleaner and it will be much easier on your hands to cut it. Okay, so let's put this away. Okay, we'll start with the bottom plate. And the first thing is safety glasses, guys. This carbon fiber is very hard, very stiff material, and when you do little cutting, little trimming, there will be little bits and pieces flying around, and you don't want those little pieces end up in your eyes. Okay, so let's use safety glasses. Okay, so this top plate, basically everywhere you can see this little joint between the main body and the little part, that's where we make the cut. If you can get can we get a little closer? If you can get close to the main body, that's what we do. But like here, we can't really, it's not easy to get the pliers right close to this flat edge. Just do in the middle, that's fine. But like in this spot here, it's very easy to put your pliers, just line them up with this straight edge and do the cut. And there's very little cleanup needs to be done afterwards. Okay, so we just go around and cut these little parts off. Okay, and I would cut these parts off the main body first and then separate them. It will be easier. We'll cut like that. Okay, like right here, we can line up our pliers with the edge. You see, it just flew away. That's fine. Again, cut. And now we can get in a little closer and do a cleaner cut. It'll probably be better like this. And it's good to align these pliers with a flat surface. It's not really good to, if you do it this way, you kind of squash that material and it will make like a dirty cut. So, but that's not a big deal anyways. Okay. Okay, that's our top plate, and we can cut off the little tabs for the parts. Okay, after cutting is done, for parts cleanup, I recommend to use some medium roughness sandpaper. In my case, that is 180 grit, and just get some flat surface. And all we do is basically lay the sandpaper down, and whatever the rough or the edge that needs to be cleaned, and we just go ahead and clean. You know, the sandpaper works really well. I mean, it takes that little roughness off quickly. It doesn't take a lot of sanding at all. Okay, and so that's that one. We'll just keep checking all our little parts now. And we are done with all our little parts now. Now all we got left is these two main plates. And this is where it kind of helps to have like a little wooden block like this one, where you can kind of bend your sandpaper around and get into places where it's not as easy. It's a little tighter. And you might be wondering, what about those or the rounded edges? It might seem hard, but it's not. And the trick there is to use some kind of spray can. Just around this, lay sandpaper around, and just find where the rough spot is. You can work a little sideways, and it's very easy. Okay, before we start our build, let's just quickly go over the parts I'll be using in this build. So for controller, I'll be using NASA version 2 with the GPS. For receiver, I'll be using FreeSky X8R. Of course, DJI arms. Speed controllers, I'll be using 30 amp speed controllers, and these have been reflashed with Simon K firmware. For motors, I'll be using Sunny Sky, and I believe they 980 kV. For gimbal, brushless gimbal motors, I'll be using Quantum motor 2208. I'll be using Martinez brushless controller, and I will also install mini OSD. This is DJI product again. And really, these are the main components that I'll be using in this build. Okay, next we'll start building our brushless gimbal. Okay, before we start building our brushless gimbal, I thought it would be a good idea to show the final product. And this is a gimbal. I use gimbal off my quadcopters, and this is exactly what we're going to be building. So we get our pitch motor, we get our roll motor. Now we're going to be building this part, just the part that holds roll motor. And for that we will need these two angle or triangle shaped gussets, two of them. Then we will need a plate that goes in between those gussets and holds the motor, and we'll need the bottom plate that will hold that gussets and the little centerpiece. Okay, so now I think it's a good time to remove that protective film from that carbon fiber, otherwise it might be hard to fit the pieces together. Okay, so we get the plate, and first we need to slide in the gusset. And first you might be wondering, you know, there are two slots. Which way do I use it? Do I install it like this way, or like that? And really the purpose for this is, what this will do, it will offset this motor. It will offset closer. Let me explain it better here. As you can see here, there's not a big gap between this plate and this gusset here. And some motors might be shorter. So if they're shorter, then we need to move this assembly a little forward. And that's what this is gonna do. There's like two settings. One setting is where motor is kind of right in the center, that back part of motor. The other setting is where it's moved more towards the front. This one here. Okay, and we need the one, because we have a fairly standard motor and this is kind of on a longer side, so we need these parts to be joined like this, right? Or no, I take that back, like this. And let's just double check and make sure that, yeah, it's accurate. Okay, so we just and really these are tabs, and they kind of slide them in and just push them over. It might be a little tight, and sometimes you might even have to I wouldn't recommend that you force or start really jamming it in. If it's too hard, then maybe just do a little tiny filing. But in this case, it's just perfect. This one's perfect too, just falls in there. Okay, and this part here, we would have to kind of open it up again. It's a little puzzle piece. And it is very precisely made, so you see it almost kind of locks itself in. And then we need a little spacer, and this spacer is gonna go right in here. So we need spacer, and we need 2 screws. Okay, that's that, and now we need our roll motor. And we will need 4 screws. So the wire goes up. And we're done. That's our roll motor bracket. Just like that. Next we'll be building or assembling this L-shape arm that will hold a pitch motor. Okay, for that we'll need a plate that looks like this. It will go right here. It will hold that pitch motor. Okay, here we'll need plate that looks like this, and you will also find there should be two plates like this, so we're going to be using one here, and this is where that roll motor is going to be mounted, and where we can do level or center of gravity adjustment for roll motor. Okay, and then of course we'll need two gussets, one on top, one bottom. Okay, first I would recommend that you guys install this little plate to this plate, because when it's all together it's going to be hard to put those little screws in. So we'll need actually four small screws. Okay, so and now you might be wondering, there's quite a bit of adjustment here, and it would be nice to know at least approximately where it should be, and it might be hard to see on a camera. There is actually a setting on these four slots in the center. There's a little opening or a little groove where if you push this plate one way, let's say forward, and slide it over, it will fall and kind of stick there. That's the setting for these motors. If you're using these kind of motors, I would recommend that you use this setting to start with. Later, if you need to do little adjustments, then you just loosen the nuts and do a little adjustment. But for these motors, for this camera, start with this setting here. So what we need to do is we need to find that setting right there. It kind of falls in place. Tighten the first one so that the other one should be easier. Okay. It's tight, and I wouldn't make them super tight because you might have to come back and do the adjustment, but it is good enough for now. So okay, so this is how it's gonna go. Okay, we got this. Next I would install at least one this standoff to the gusset. See, I need this and this. Now this is not the right. Oh, this is the right one. Put these two together. Yeah. Right, so this is top. Yep. And this is bottom. Yeah. Let's put that second screw in. And this is our L-shaped bracket now. So it's gonna go. Okay, so next we will work on assembling a camera pitch assembly, which is this part right here. And for that we will need two of these gussets. There will be one on top, one on one side, one on the other side. So that's those two. At the bottom you'll need this plate that holds the camera. It will go in between these gussets. In this area between the gussets we will be using this plate. It will be kind of mounted in between these two side plates so it can move. And we'll need this motor plate, which will sit on top of that plate in between those gussets. This will give us center of gravity adjustment for pitch axis. Originally, when you purchase these brushless gimbals, Martinez board, you might get something like this. This is that IMU board, and this is just one type or one version. There are a few boards that are a little different shape, a little smaller than this one, but this is very common. And so you will get this, and you will get leads like these for the wiring from the board to the main controller. And with this little board you will get these little header pins that you would have to solder in. But in our case here, we won't be able to use those header pins. We'll just need to we'll need to solder the wiring directly onto the board. And I already gone ahead and made this little harness, and this is what I'll be using. And also, instead of these wires that came with the brushless controller, I'm using like much thinner, much more flexible wires. These are 32 gauge. These are probably like 26 gauge or so. Okay, so first let's mount this one onto this board. We'll actually go, it will go just like that. And then it will route the wiring through this little opening here. Okay, so let's get 2 screws. And what I would do, I would put the screws in first in here, like that. That's one. That's 2. And what I usually do, I put a little that's 2mm nut here, and they'll serve like a spacer between this board and this carbon fiber plate and this little IMU board. And this way, this first nut will kind of squeeze through that heat shrink, and it will be flat against that surface, the board surface. And that's what we want. Okay. And now this will mount like this. Just need 2 more screws. And these bolts right here, they're just perfect length. There's no extra thread sticking out after we all done. That's one. There's the second one. And now all we need to do is I'll just disconnect this header pin. This is what came with the little board. And now we just need to route these connectors through that hole. Okay, almost there. And that's it. And if you can notice on a camera here, let's see. I actually filed like a little groove right here. Just took a little bit of filing, just a little bit, slightly. And the reason for that is, if you can see it here, so this wiring is excuse me, so this wiring is routed through this plate and this spacer, and that gives it kind of secures the wiring right here, so there's no way this wire can be pulled off this little board. It's just an extra security, and that's what we're going to do on this one. So I did the little routing already, so that's done. It will be mounted just like that, and there will be spacer right on top of it, so it's going to be like squeezed in between. Okay, so that's our little IMU board. Now let's just take and as we did on this part, just install the spacer first, and that's going to be this one here. That's this one here, yeah. And I would do that, this spacer at the bottom, this is bottom, this is top. Do this one first. Well, actually we can install both of them right now. It'll be easier. Before we continue, we need to do the same thing as we did with this part, where we install this little motor plate first. And like I mentioned before, otherwise it's gonna be hard to get in there and put those little nuts on. So let's do that right now. Okay, and again on this one, there's the same kind of notch in those slots where which is basically a setup or the setting for these kind of motors, and that's where we should tighten these bolts. So if you slide this, it will kind of fall in place right there. So this is where we need to tighten the bolts. Okay, right there. So after we got the motor plate installed on the center plate that's going to go between these two gussets. So the one gusset, the gusset with two spacers, let's put that one down flat on a table. So this is top, this is bottom, this is inside, this is outside. This plate that holds the camera is going to go right here. This plate that holds the pitch motor is going to go here. And here just you see this motor plate, this square one, that goes on outside. And also you'll see that this plate doesn't sit right in the center. There's little greater distance on top and smaller distance on bottom. So where you see that longer distance here on top, that goes towards the top, and the smaller distance towards the bottom. Otherwise the motor is going to sit too high. And MPU unit goes will go right here on top. Okay, so all we need to do is put these little parts together. Again, it's just tabs and slots, so you just push them in place. That's that one. And we might have to remove this spacer later so we can route this MPU unit harness through that plate and the spacer, but that's not a big deal. So this is in place. We'll put the bottom plate in. Okay, and we put the other gusset, the top gusset on it. Just line up the tabs, and that's it. So now we can put one screw in so it doesn't move on us. Okay, we can tighten that up a little bit. That's good. Okay. So we get the pitch motor installed already on this L-shaped bracket, on the roll bracket. And we can install this one, the pitch platform. And for that we'll use the screws that came with the motor. That's it. That is our roll motor assembly. And now we can install this assembly to the roll motor. So next, while we're here, we can just play with this, see how is the balance, where's the center of gravity. Okay, this is just a regular GoPro 3. On this one, you see how I have it here, a Velcro strip. What works really good is just, you know, use these Velcro strips that come or sell for, usually they use for strapping down the battery. What I did is I cut it on half because as it is, it's a little too wide. It's gonna be, it needs to be like right here, so it clears the button and it goes right around the center. So it's a little too wide right now. So what I did, I just cut on half. Okay, so now we can install our camera. And just in case you guys wonder, this is a little wider than Hero or GoPro 3 is. It's a little wider, and the reason for that is this will also take GoPro 2 version camera, and for that will fit in right in there snug, nice. And for this you might need to move, do the little adjustment here in the roll motor, because this is a little heavier camera, so you will need to slide this a little that way. Okay. So we put the camera in. You know, you might think this is a little tedious, but it is tedious only for the first time, because after we put it in, put the camera in place where we want it to be, what I'm gonna do is I'm gonna put a little bit of glue to glue this Velcro piece to this bottom plate. That way, next time it will, just like on this one, you just slide the camera in and zip tie it down, or not zip tie, but Velcro it down. Okay, so our gimbal, this is our roll pitch motor, and we can maybe kind of strap this around a little bit so it stays in place. Okay, yeah. So there's, I mean, these motors, they have little like magnets in them, so they, but you see this is pretty well balanced, so even with those little magnets in the motor, it doesn't overpower this. And if this would be like way out of balance, wouldn't be well balanced here, this is where we would do the adjustment. We just slide this little plate up and down. But for this is fine. This is good. And roll. The same thing. It pretty much stays wherever we stop spinning. And that's what we want. So this is well balanced gimbal now. Okay, so first we will be working on the top plate. And so for the top plate, we will be installing a power distribution board. And this is going to be, we will solder 2 connectors on top of this board. This way you actually can use 2 batteries in parallel. Okay, just like that, and it will be mounted on a board. So the power distribution board is going to go right here. Mini OSD will be mounted on this top board as well. And this will be mounted in the front like this, and this part here will be mounted in the back like this. So where this OSD unit is gonna come around and plug into this unit here later when it's assembled. And GPS compass is going to be plugged in here. So OSD, PMU unit, power distribution board, solder 2 JST plugs. and one is gonna be a plug for brushless gimbal controller power supply, and the other one is going to be optional for like FPV transmitter, the video transmitter. Okay, so I already gone ahead and installed the power distribution board and 4 DJI arms on this top plate. Also, what I did, I soldered 2 XT60 battery connectors on this power distribution board, and if you flip it around, you can see now you got these 2 connectors, and the batteries could sit right here on the back part, and just plug the batteries in here, and you have an option to plug in 2 batteries or install 2 batteries. Okay. Also, if you notice that there's a little gap between power distribution board and this top plate, and that is for I usually put a FPV battery, like a smaller battery here, and this is so you can route a Velcro strap through there and tie down your battery. So you get your FPV battery here and the main battery or 2 in the back. Okay? So that's our top plate. So the next thing what we need to do is we need to solder these 4 speed controllers onto this power distribution board. And 2 of these speed controllers, I've done that already. Usually these speed controllers come with the standard length wires, and the front ones might be a little too short, so what I have done here is already extended them a little bit. Okay, so these will be soldered right here, and the 2 back ones. And the back ones should be fine as they are. The length on the wiring should be fine. And that's what we're going to do now. Before you do any soldering onto this power distribution board, I highly recommend that you zip tie down these speed controllers onto the arms. That way they don't move, and you always have the same length of wires going to the motors. Okay, so pretty much done with that top plate assembly. So what I done, I soldered the speed controllers onto power distribution board. I installed that mini OSD in the front part of the copter, and I installed that PMU unit, NASA's PMU unit in the back right behind this power distribution board. I also put a little bit of hot glue just to tidy up the wires so they stay nice and tidied up. Okay. One thing I want to mention, when you guys do set up this the same way, use the same parts, this PMU unit, don't install in the center. Kind of install it a little off center, and if you can tell right here where that PMU unit and that power distribution board, this edge is in one line. The reason for that is if you install in the center, it's going to be hard to plug in this GPS cable connector. Okay, so just offset a little bit. The same here. This one kind of position so you can easily plug in that wiring, that video in and out, and also make sure that that mini USB port is accessible, so you don't have to fiddle around, and so in case if you need to reprogram or change some settings in this OSD unit. Okay, so that's our top board, and of course these 2 will plug into NASA's controller. Okay, so next let's work on a bottom plate. For the bottom plate, let's just lay out the parts how they're going to be sitting on the plate. For brushless gimbal, the controller is going to sit right here in front of the frame, and what I've done is I soldered these header pins and this power lead. So this is going to sit right here. Controller, so again, this is front, this is front, this is back. Controller is going to be easy because if you are using NASA controller, the center of gravity, it's clearly marked. You can see these like angle shaped notches in each corner. That's where that NASA controller sits. Like, as long as you kind of match it up, that's the center of gravity. Okay, so it's our brushless gimbal controller, NASA controller, the flight controller, our FreeSky receiver, FreeSky receiver. We just pull it out carefully. FreeSky receiver will be sitting right here, and I'll be using that S-bus connection, so all I will need is just one lead from the receiver to controller. This is where we're gonna put our receiver, and that NASA LED unit put that one in the back. And if you notice, there's on the frame, there's like these notches, an opening in the center, and that is for this LED. You want to face this LED down like this, and what I'm gonna do is you're gonna use a heat shrink and just secure it right here, and this way just turn this around. If you're looking from the bottom up, that LED will be always visible, and you can always see what the status of controller is, the NASA controller. Okay, so let's mount all these pieces in places. So at this point we got our bottom plate and top plate assembled. Just a little bit on this bottom plate. So I mounted this LED unit in the back. As I said, I used the heat shrink, but I did put a little bit of hot glue in front. That way it won't slide when you plug in or unplug your USB cable. Then I routed all this wiring, the extra wiring on top of this receiver. Just plug it in. So this is our NASA controller, and brushless gimbal controller is bolted in up front. Now what I would recommend you guys to do, find your receiver and set the throttle range on all your ESCs before you put these two parts together. Otherwise, after you put it together, it's going to be really hard to do that throttle range setup, because it's going to be tough to get in there and pull those wires apart. So better do it now, and that's what I'm going to do now. I'm gonna bind my receiver, and I'm gonna do throttle range set. Okay, so what I have done is I already bound my receiver with my radio. I added an extension lead from channel 3, which is throttle, and I'm also powering my receiver with the separate UBEC power source. Okay, so to set the throttle range, this is what we need to do. So we turn the radio on.
Welcome to throttles.
We position the throttle at the max position, which is all the way up. So we're gonna do throttle range setup on this ESC. So this is this wire here. So we're plugging in the battery, and this battery will supply power to all the motors now. And now we want to plug in this extension into this speed controller lead, and just make sure that black is black, white is white. Once you plug it in, we'll hear these beeps, then throttle all the way down, a few more beeps, and we're done. So now we can unplug it, and the throttle range is set. And just to make sure, you can plug it back in. So connect this, and now this motor should spin. So we successfully set the throttle range on this motor, and we just need to do the same thing, follow the same steps for all the other 3 motors. Okay, so one last thing what we need to do before we put the bottom plate and the top plate together is add this servo extension lead from the receiver to gimbal, and this is gonna be for our pitch control, so we can tilt the camera down and up as needed. Okay, I'm using this channel number 8, last channel on this side, and this is where it plugs in. Okay, so our quadcopter is almost completed. So we got both bottom and top parts bolted together. I installed the little standoffs in the back. This wiring, the loose wiring, we'll worry about a little later after set the right motor spinning direction. The last thing we need to do is install our brushless gimbal, and really there's not much to it. What we need to do is we just need to install these vibration dampeners in there, and then install them in front too, and then it's just plugging these wires into the brushless controller. Okay, so I gone ahead and installed the brushless gimbal. I used 6 vibration dampeners, 2 in the back, 4 in the front, and for the ones in the back I put like a nylon screw through, because if you see on these dampeners there's a hollow center, so I put a nylon screw through with the nut on the back side, and that is just an extra security in case if there's some more pressure applied on this brushless gimbal, the whole assembly doesn't pop out. Okay, these 2 screws, they don't stiffen up the platform. It still does a really good vibration dampening. Okay, then of course I plugged in this MPU harness and the motors into brushless gimbal's controller. What else? I installed that NASA's compass stand, and I routed the wiring through this opening and plugged it into, if you can see, into NASA's PMU unit, and that is pretty much structurally assembled, completed quadcopter. Of course we need blades, but that will be after we do the software setup. Okay, our quadcopter has been fully assembled, it has been fine-tuned, and basically it's ready to fly. I just want to take a few moments and go over of some general characteristics of this quadcopter, like the distance between the motors, like the weight, the center of gravity, and a few other things. Let's start with the distance. So what is the distance between center of the motors front to back? And this is going to be in millimeters, so, and that will be, so the front to back is 355 millimeters. side to side is going to be 365 millimeters. So it's 10 millimeters wider than it is front to back. Okay, now let's just check the diagonal measurement. And that is going to be, our diagonal measurement is 515 millimeters. Okay, it's basically 500 millimeter frame. And next, so let's check the weight. So how heavy is this frame now? And right now I have two 2200 milliamp batteries installed, and I have the GoPro installed. I know these two batteries weigh about 400 grams, so about 200 grams each. And the GoPro is about, I believe it's about 100 grams. So GoPro and the batteries is around 500 grams. Okay, so let's see our scale. And the whole frame weighs, it is 1,638 grams. So without these two batteries and the GoPro, it would weigh about, it's a little over 1,000 grams, 1 kilogram. Okay, so that's the weight. Center of gravity. So as we all know, we want a center of gravity as close as possible to perfect again. You know, where our flight controller is mounted. So our flight controller currently is mounted in the center of front to back and side to side between the motors. And if you look carefully on top, you'll see two small holes, and this would be actually your center of gravity line. I got a little center of gravity tool, so let's just line this up. Put on the edge, it has like a sharp edge, so you get a somewhat accurate measurement or test. Okay, right now it's kind of leaning on towards the back, but if I, right now this edge is lined up with these two holes, which is the center of gravity. It's kind of leaning back, but if I push it forward, it stays forward. And that is basically because the mass on this quadcopter is not the same level. Once you lean it over, the weight shifts over a little bit. I mean, I could spend probably few minutes and get it right, but as it is right now, it is very close to, I would say, perfect center of gravity. Okay, what else? You probably notice these two receiver antennas. They are spread about, see this one, this is the second one, and this is a diversity receiver antenna, so it has two antennas, and ideally you want these antennas to be spread about 90 degrees, and that way you get a better signal coverage. So what I have done here is I just use like a zip tie or cable tie around this standoff, and so I laid my antenna and put a little heat shrink on it, and this way these antennas are staying, you know, spread at 90 degrees, and that's what we want. On our gimbal, you might notice that as it is right now, if I push this camera down, it will actually hit the ground, well, in this case it will hit the table, and in other words, this frame sits very low. If you do want to raise your frame up a little bit, and if you've been searching on the internet, there are actually like legs, especially on the DJI frames, you can buy, and basically it will lift the frame up and it will stand on the legs. Myself, I don't like my quad to be up high, because it's just, in my opinion, it's not as stable. But in this case, this is a little too low. So what I found, what works really great is use this, I believe it's called swimming noodle. It is a round, it's very light material. Well, apparently it floats well. In this case, this is about 2.5 inches in diameter. What I have done is I just cut a little, like a slice about 1 inch wide, which is 2.5 centimeters wide. I think I've done some already, like this one. So I made 4, and just make a little cut here in the center, just to this from the center to the center, not all the way through. And then all we need to do is just kind of, let's see, just press this onto the arm's leg, or whatever you call it. And let's just do that on all 4. You don't really need any glue, anything. Okay? And as you can see right now, the gimbal actually could spin all the way around. Okay. So it gives you like little shock absorbance. So this pretty much concludes this FPV360 Quadcopter build video, and I hope that some of my suggestions, tips are going to be helpful for you guys. And I do understand this was a lengthy video, but again, I want to thank you for watching it all the way through, and I wish you guys a good luck and success in your next quadcopter build. Thanks. Bye.